In this video, I'm going to demonstrate the process to import our superelevation definition from a CSV file. So taking a look at ODOT's training material for superelevation, we have on, what page is this? Page 506-8 defines the format for the CSV file. So the format is the name of the superelevation lane, the station, the cross slope, and then a pivot about parameter. The pivot about parameter is telling it whether this particular lane is going to pivot about its left edge or right edge. So there's an example of the data, name of the lane, station, cross slope, and this one's pivoting about its left side. So our workflow is going to be to create the CSV file, create our superelevation section and our lanes. Then we'll import the CSV file and follow the heads-up prompts as we import that to define the parameters. So I'm going to start by creating our superelevation section. So I'm in the Open Roads Modeling Workflow, the Corridors tab, and I'll use the Create Superelevation Sections command. And I need to give this section a name, so I'm just going to name this SR185 CSV Import and pick my alignment. We're going to start from the beginning, so I'll use the alternate to lock to start. Go to the end, I'll use the alternate key to lock to end, accept those values, and I use a minimum tangent length of 0 here. So I'm going to define my first lane, and I'm going to define the left lane, and I'm making sure that's the name I used in my CSV file. And I forgot to open the CSV file, so I'll show you that after I complete this. So we'll do the left lane. It's on the left side, starting at the inside offset of 0 from our center line, 12 feet wide, minus 1.6% slope. Now I'll define the right lane, and the side is right, starting at inside offset of 0, 12 feet wide, and a minus 1.6. So I'm done defining lanes, so I'll just reset out of that. And the function is going to want to take me to the Calculate Superelevation tool. I'm not going to use this tool. I'm going to bring the superelevation in from my CSV file. So I'll just select a different command, the element selection command, just to get all of that. So at this point, I have my superelevation section definitions, and I have my lanes defined with no superelevation. So I've got a CSV file that I've already defined, and I'll open that and just take a quick look at that. So there I've got my name of my lane, my station, my cross slope, and my rotation or pivot point for the left lane and then the right lane. So I'm going to go ahead and import this file. So to do that, under the Calculate group, I'm going to choose the Import Superelevation command. So I need to browse for my file, and I'm going to go ahead and choose that. Okay, so I've got that under my Ohio DOT work sets. 1, 2, 3, 4, 5 is my PID, under 400 engineering roadway, and then engineering data. So there's my CSV file. So I'll go ahead and open that. And it's asking me to identify the superelevation section. So I'll pick this one and go ahead and accept the CSV file. And let's get this section and accept that CSV file. So when I'm done, I can see that I have color now for each of the lanes and their transitions. And if I select my section, I can review my values, and I can see that I do have superelevation assigned. I'm hitting 8% here, transitioning out to my spiral. So there's my half flat, 0%. So it looks like the values have been assigned correctly. So that's just an alternate way to define your superelevation and import that and assign that to your lanes. If you'd like to use that rather than using the ODOT tables to compute it, this is advantageous that allows you to compute the values ahead of time, put it in a CSV file, and then just import those values.